I'm not recording. Hello, MJ and Kelsey. MJ and Kelsey.
Yeah,
it's fine. I'll just do it this way.
Okay. About you. Hi, MJ.
So we are on the second page, and I said refer to this diagram right here, this little thing, okay? And also have your unit circle handy, yes?
Yep.
Okay. On your unit circle, okay. Let's see. I'm gonna do this real quick. I'm gonna put my unit circle right next to this guy so that we can have him ready to go. Where is my unit circle? Right here. No. Keep going right here.
There it is.
Okay. Gotta scroll all the way down. All the way down. But not too far. Okay, there we go. So, all right, your unit circle. I want you to take a look at this piece right here. X, Y, cosine, sine, right? We said the cosine value is the x coordinate and the sine value is the y coordinate. Okay? Do you guys remember that? So if I say find cosine of 30 degrees, what's cosine of 30 degrees? Cosine is the x coordinate, it is square root of 3 over 2. Yeah? Okay, so keeping in mind that cosine is the x coordinate and sine is the y coordinate, okay? Take a look at this little box that you have on your note sheet. Have these side by side, okay? Sine is the y coordinate, cosine is the x coordinate, right? Sine is the y coordinate, cosine is the x coordinate. Sine is the y coordinate, cosine is the x coordinate, sine is the y coordinate, cosine is the x coordinate, okay? Taking a look at this box on the second page of your notes, okay? If we are looking at an angle in the first quadrant, like 30 degrees or 45 degrees or 60 degrees, okay? In the first quadrant, all of the x values should be positive, and all of the y values should also be positive. Does that make sense? Looking at your unit circle, all of these numbers over here, the x's and the y's are both positive. Yes? So sine and cosine, if it's an angle between 0 and 90 degrees, 0 and 90 being the first quadrant, if it's an angle between 0 and 90 degrees, your sine and cosine value should be a positive number. Yes?
Yeah.
Okay, now looking at the second quadrant. I went too far. Looking at the second quadrant, the y coordinate is positive because you're going up, but your x coordinate is to the left, so your x coordinate is negative. Does that make sense? Okay, how those work? So if you are dealing with an angle between 90 and 180 degrees, if it's an angle in here, maybe it's 150 degrees, the sine value of 150 will be a positive number, but the cosine value will be a negative number. Because in the second quadrant, yes, it exactly goes together, right? Cosine is the x coordinate, and x's that are over here are negative, and y's that are over here are positive. Let's look at the unit circle to validate that. Over here, look at all the x coordinates. Every single x coordinate here is negative. Every single y coordinate is positive. So sine is going to be positive. These are the sine values, and these are the cosine values. All the cosines are negative, all the sines are positive, yes?
Yes.
Okay?
Yes.
All right, so go down to the third quadrant. If it's an angle between 180 and what's this angle down here?
270.
270. If it's an angle between 180 and 270, angles that are down over here are to the left and down. So the x's are negative. The y's are also negative. So all of those coordinates, the sine and cosine values of an angle between 180 and 270 are both going to be negative. Yes?
Correct.
Okay, let's validate that with the unit circle. I'm making you dizzy. I'm sorry. Down over here, the sine and cosine values are negative of everything that's in the third quadrant, or angles between 180 and 270. Yes? Does that make sense? Okay. And the fourth quadrant, we're talking about things going to the right, which means the x is going to be positive, and things going down, which means the y coordinate is negative. To the right and down, the x's are positive, the y's are negative. So sine of an angle between 270 and what's this angle right here? 360. Anything between 270 and 360, the sine value is going to be negative. The cosine value is going to be positive. Is this making sense? Okay, so let's test your knowledge of that. Okay, ready? Okay, I'm dealing with x's that are positive and y's that are negative. What quadrant am I in? The x's are positive, the y's are negative. Right? X's go left and right, so I'm going to the right, and y's are negative means I'm going down. So I am in the fourth quadrant, right? Okay? Now let's say I say the sine value is positive and the cosine value is negative.
4. 2.
2.
Oh, yeah.
Sine is the y coordinate and cosine is the x coordinate. So the x's are negative, which means we're going left, and the y's are positive, which means you're in the second quadrant. Does that make sense? So whatever the y value and the x value, the sine and the cosine value, you can figure out what quadrant you are in. What?
It goes like 1, 2, 3, 4.
Yes, 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 yes. If you need to label that, 1, 2, 3, 4. Okay, maybe that's a good idea to label those. Those are the quadrants if you didn't already know that. Okay? Now, one other thing that I want to point out is this. Right on here, right on this little circle down here, that this is 0 degrees, right here. This is 90 degrees. This is 180 degrees, and this is 270 degrees. And then I'm also going to say slash 360 because 0 is the same thing as 360 degrees. Those things are, do you remember what that word was called? 0.
The same.
They are the same. They are
Alike.
starts with a C. They are coterminal, right? They have the same terminal side, right? Coterminal. Okay. Now, rather than writing them like with degrees, they do this thing right here. They're saying T, or my angle, lives between 0 and pi over 2. Because in radians, 0 degrees is 0, but in radians, 90 degrees is actually labeled as pi over 2, right? 180 degrees is represented as pi, yeah? 270 degrees is represented as 3 pi over 2, and 360 degrees is represented as 2 pi, because a full circle in radians is 2 pi, right? Okay, so this is what they're saying here when they say this. They're saying that my angle which we're calling T, if it lives between 0 and pi over 2, that's just a fancy way of saying my angle is somewhere between 0 and 90 degrees.
Yeah, why don't they just...
Okay, but they're doing it in radians.
Think about it.
They want you to think about it, okay? So, between 0 and 90 degrees, okay? Then they say pi over 2 to pi, and that's just a fancy way of saying that my angle is living between 90 degrees and 180 degrees. That's just a fancy way of saying that, because we're in radians instead of degrees, okay? This right here, if I convert those, pi is the same thing as 180. 3 pi over 2 is the same thing as 270. So this is just a fancy, this right here is a fancy way of saying that my angle lives between 180 and 270, okay? And then this right here is just a fancy way of saying that angle lives between 270 degrees and 360 degrees.
Or 0.
Or technically 0, right?
Hold on.
Okay, does that make sense?
Yeah.
So when they're referring to that, they're saying that this is what quadrant you're living in, basically. What quadrant your angle is. Yeah?
Yeah.
Good?
Yeah.
Kinda?
Yeah.
Okay. All right. This table that we have over here is a table that we've already filled out in previous sections. It's just saying the sine value of pi over 6, the sine value of pi over 4, the sine value of pi over 3. These are each values that are on your unit circle. 1/2, square root of 2 over 2, square root of 3 over 2. Those are sine, cosine, and tangent of those special angles. Pi over 6, pi over 4, pi over 3. Pi over 6, if you look on your unit circle, this is how many degrees? Pi over 6 is how many degrees? Look on your unit circle.
30 degrees.
30 degrees. Pi over 4 is the same thing as
45.
45 degrees. Pi over 3 is the same thing as
60 degrees.
60 degrees. Do you see that on your unit circle? Okay. Pi over 6 is the same thing as 30. Pi over 4 is the same thing as 45. Pi over 3 is 60 degrees. Okay. Those are on there, right? Okay. All right, so let's go down here, and using your unit circle, you're going to flip back and forth between your unit circles, so have him handy. We're going to fill out this table according to 0, pi over 2, pi, 3 pi over 2, and 2 pi, okay? So the sine is which one again, x or y?
Y.
This is the y, cosines are the x's, and then the tangents on your unit circle are labeled. So go to 0 degrees or 0 radians,
1, 0.
and what is the y coordinate at 0? 0. What's the x coordinate at 0? 1. And what's the tangent value at 0? 0, right? It's right over here. We're looking at the y is 0, 1, and the tangent value is 0. Okay, now we're going to do pi over 2 next, which is this one. We're using this information, okay, at pi over 2. So pi over 2, what is the y coordinate at pi over 2? 1. What's the x coordinate? 0, and tangent is? Undefined. Okay? Going to pi. Do you guys all see where these numbers are coming from? If not,
Yeah.
stop me.
Right there.
Okay? Pi. What is the y coordinate at pi?
0.
0. The x coordinate?
-1.
-1. The y coordinate, or the tangent value, is 0. Okay? 3 pi over 2? -1. 0 and undefined. And then 2 pi. But we've really kind of already done 2 pi because 0 is the same thing as, it's just copy those two tables, those two columns are the same, right? 0, 1, 0, because 0 is the same thing as 2 pi, yeah? Okay, you seeing how to read this unit circle a little bit? Okay, let's go and let's talk about something called a reference angle. Okay, you got to really pay attention to this because they ask you a lot of questions on your homework about a reference angle. A reference angle, okay? So let's talk about 3 pi over 4. Okay, 3 pi over 4, and we have to figure out where that thing is going to live. Okay, 3 pi over 4, where is it going to live? You have a 3 pi over 4 on your unit circle.
135.
It's 135 degrees, which is in what quadrant? The second quadrant. This is an angle of 3 pi over 4. It's 135 degrees. You have it on your unit circle. 3 pi over 4 is right here, 135 degrees in the second quadrant, okay? Now, ready? Reference angle. This is how you draw a reference angle. We first draw the original angle. This is what a reference angle is. It's the bow tie concept, okay? So this terminal side here, I make him into a bow tie, so I have to connect him back down, okay? And I want to figure out the reference angle, which means I need to figure out what this angle is right here. It would be what the angle theta is, okay? Ooh. So, doing this confuses a lot of people, okay? Ready? 3 pi over 4 is from here to here. How far is it if I would go all the way around to the bottom?
180.
180, which is in radians, is pi, right? It's pi from here all the way around to here. But I'm only going to 3 pi over 4. So how do I figure out this right here?
Subtract.
Yeah, it's this angle is 180 degrees basically minus 135, which is 45 degrees, but they want it in radians. So instead, we could convert it, yes. So, or we could do pi minus 3 pi over 4. Okay, wait, what? In radians, 180 degrees is pi, right? 135 degrees was our angle, 3 pi over 4, and we subtract those two. But I need to find a common denominator.
4 pi over 4.
4 pi over 4 minus 3 pi over 4 is just
Pi
over 4, which is equivalent to 45 degrees. Okay? So, your reference angle, which one are we going to give as the answer?
Hold on. Wait, Mrs. Comager, why did you do all that?
Let me try my way, and then
So we
we'll
could
see
get
if
45?
you could have just
Why don't you just look to see what 45 is?
You could. But the whole deal is, some of these, like 11 pi, we do have 11 pi over 6. So some of these won't appear on here, is the deal. So some of these you won't have on your unit circle.
So we need to know
So
how to do
you
it.
would have to convert it to degrees and then convert it back, right? You can just look on your unit circle. So if you want to not have to convert to degrees, all you'll have to do is take pi minus whatever angle that you have, right? Does that make sense? So they're asking for the reference angle, and that is pi over 4. Okay? Now, that's not all they ask for. They say find the sine of t, find the cosine of t, and find the tangent of t. But all you have to do is look on your unit circle. Okay? So, 3 pi over 4 lives here. And I see these two pieces right here. I have negative square root of 2 over 2 and positive square root of 2 over 2. Negative square root of 2 over 2 is the x. So that is the which value? Cosine. So cosine is going to be negative square root of 2 over 2. Sine is going to be positive square root of 2 over 2. What's the tangent value at that place? You look. I know it.
-1.
Negative 1. Tangent. There it is. Okay, negative 1. Good? Yeah?
Wait. I'm sorry.
Just
I'm
pause.
trying because my iPad is done.
I forgot.
Let my mind catch up.
Okay.
How did we?
These are kind of difficult to find the reference angle, at least. Reference angle is a little bit harder. Okay? All right? Are you ready? I'll wait.
It goes backwards, basically.
God, I hate this part.
Wait, why is it backwards?
Oh, we're almost done. Okay.
Tangent cosine
This
Don't
makes
let
me feel
this
bad.
is garbage.
of t.
Sorry.
And t is 1/3.
Oh,
Yeah.
fine. Fine.
Fine.
So we can do bigger and better things later on. It doesn't
Wait,
make a whole lot of
wait,
sense now,
Which one
but
is sine on here? Which one is
sine is always the y.
Goes backwards.
Okay, are we ready? Ready for 4 pi over 3?
This is gross.
It's kind of gross.
I'll never eat it.
These next two, that's why I have 3 examples here, so that you can kind of get warmed up as you go, okay? 4 pi over 3
Okay.
is on your unit circle. 4 pi over 3, what quadrant does it live in?
3.
Okay, let's say you don't have your unit circle handy, and I'm gonna show you kind of how easy this is, all right? 4 pi over 3, ignore the pi, right? Ignore the pi. 4 over 3 as a decimal is 1.3 repeating, okay? Here is where 0 lives. 1 pi lives here, and then we go back around and it's 2 pi over here. So 0, 1 pi, 2 pi. Where is 1.3 going to live? This is half of a pi. So this is 0.5 pi. And this is 1.5 pi. Do you see that?
So pi is
Halfway
between the
between.
one
Okay,
and
so
the
do you
one.
see how this works? 1.3 is going to be in the third quadrant, right?
Oh,
Because it's 1 pi, 1.5 pi, 2 pi, half a pi, all the way around, right? Okay, so 1.3 is going to be in the third quadrant, right? Okay, so if you don't have your unit circle, you can kind of figure out where he lives, yeah?
Yeah.
Okay, all right, so he's in the third quadrant. Now, we need to make a reference angle. So we need to figure out what our bow tie angle is going to be. So where do I connect him back to?
Up.
I connect him up. And I need to find out what this angle is. Okay, now this is a little bit different from the reference angle that we had before, because before we were in the second quadrant, now we're in the third.
Uh-oh.
Ugh.
Just do 270.
So
Bigger.
we know that from here around to here, this is 4 pi over 3, right? And I want to know what just this piece is right here. Okay, so how far is it from here to just here?
180.
Which is just pi, right?
So it's going to be 3
So before we were taking pi, let's see, we were taking pi minus 3 pi over 4. But in this case, we're taking 4 pi over 3 minus pi in this case. Okay, let me show you if you're confused. 4 pi over 3 is from here all the way around. I know that from here to here is just pi, and I want to subtract those two to find this distance right here, right? Does that make sense? 4 pi over 3 is the whole thing. Pi is just that top part. I want to subtract those two, okay? So I take 4 pi over 3, and I subtract pi.
Why don't we do 270?
So
Because that would be an hourglass. We're doing bow ties. 270 would be this guy right here. We don't want that angle. We don't want that angle.
said that.
Okay?
Pi over 3. That's the answer.
All right. So you said minus 3 pi over 3,
Yeah.
which is just pi over 3. That's the reference angle. Pi over 3. Okay? Yes? Do you see how to find the reference angle?
Yeah.
Yeah? Now we need to find sine of t, cosine of t, and tangent of t. And those are on your unit circle because we do have a 4 pi over 3 on your unit circle.
Negative square root of 3 over 2 is sine.
Negative square root of 3 over 2. Is he right?
Yes.
Okay. They're both negative, right? Because we're in the third quadrant. So both sine and cosine are negative, right? So negative 1/2 is the cosine. Is that right?
Yep.
Yeah.
Yes. Yes. Tangent
Square root of 3.
is just square root of 3. Okay?
Next, where do we get that?
Finish this off.
Because 4 pi over 3 on your unit circle is this guy right here. Okay? So cosine is the x coordinate, sine is the y coordinate, and tangent is that
Can
value.
you go back?
Okay? You're just using those guys.
Okay.
All right? I'm going back.
Can you listen to that picture?
Okay? The last one is 11 pi over 6.
It's in the fourth quadrant. I
Yeah,
just
I know,
figured
that's
that
what
out.
I-
Oh, it is.
11 pi over 6 on the unit circle. Same thing. Same thing again, right?
Yeah.
Okay?
Will there ever be one that's not on the unit circle?
Yes, but then you're going to subtract pi over 2 pi or add 2 pi until you get something that's on the unit circle, like what we were doing before, like yesterday, right? You'll get it to the point. I think that's what this next example is saying. Yes, right here. Okay, so that's the next problem. All right, 11 pi over 6. Okay, if you just take 11 and divide by 6, what's 11 divided by 6?
Huh?
What's 11 divided by 6?
11 divided by 6.
It's less than, little less than 2, right? What's 11 divided by 6?
1.83 repeating.
1.83 repeating. So this is 1.83 pi. So 0.5 pi lives here, 1 pi lives here, 1.5 pi lives here, and 2 pi lives here, right? If it helps you to think about it that way, what quadrant will it be in?
4.
It'll be in the 4th quadrant, okay? So from here all the way around to here is 11 pi over 6, okay? And we want to find his reference angle so we connect him back to the x. Okay, so another way, another reference angle. We've got to find this angle right here.
Go around to 2.
It's 2
270. Go to
2 pi is the closest.
Yeah.
You go all the way around.
Yeah.
Okay?
2 pi.
All right, are we doing good so far?
Yeah. I just said
Okay,
2 pi.
so all the way around, you said? All the way around was 2 pi. No, because that would be a bow tie, that would be an hourglass. 2 pi is the whole circle, right?
Yeah.
2 pi is the full circle. Then from here to here is just 11 pi over 6. We're trying to find what this angle is, so we're going to subtract the 2. Right?
2 pi.
2 pi minus 11 pi over 6. 2 pi minus 11 pi over 6. And as a common denominator, 2 pi will become 12 pi over 6 minus 11 pi over 6. So the reference angle is
I'm lost.
Pi over 6.
pi over 6. That's my reference angle.
Got 'em.
Mrs. Comacher.
Lost.
I lost you. Okay.
Yep, I'm lost.
I thought it was 2 pi minus 2 pi.
I thought 360
Yeah, but you
was-
have to have a common denominator, so
I
you
thought
multiply it by
360
2.
was
It's 2 pi minus 11 pi over 6.
0 is 0.
So 12 pi over 6 minus 11 pi over 6.
I thought 270 was 2. On the circle that we went.
No, no, no. 2 pi is 360,
No,
darling.
270 is.
I know what we're doing. Don't worry.
Okay?
I know, but why
All right, so
I don't know.
you want me to walk through again why it's 2 pi minus 11 pi over 6? 2 pi is all the way around. 11 pi over 6 is how far I've gone. So if I want to go the rest of the way, I have to subtract the 2. 2 pi, the full circle,
I'm done.
minus 11 pi over 6 will give me the rest of the piece that I need, right?
2 pi. Oops.
Okay, my reference angle is pi over 6. Now we have to find sine, cosine, tangent.
I did that already. I'm done.
Nobody asked.
Caleb's on a roll. You people are watching this video. If you don't understand, go see Caleb because he's on a roll right now.
I can't explain very well.
Okay. Never mind, don't go see Caleb. All right, sine. If you're looking at pi over 6, 11 pi over 6. 11 pi over 6 down here in this corner. So you're looking at this information
Yes.
right there. Yeah?
This is mine.
Okay? Sine is the y coordinate, which is
Negative 1 over 2.
negative 1/2. Cosine is positive square root of 3 over 2. And tangent is negative square root of 3.
Right here.
Negative square root of 3.
Over 3.
Over 3. Over 3.
I was looking at
Yeah.
the wrong-
Negative square root of 3 over 3.
Oh.
Yes, good. Okay, last one, almost done. We're doing the same thing here. Find sine, cosine, and tangent of 7 pi over 3, except I don't have 7 pi over 3 on my unit circle. 7 pi over 3. Oh, why is it spelled sine, cosine, and tangent instead of S-I-N-C-O-S-T-A-N? This is just the full word.
Really?
That's what they look like. Sine is S-I-N-E, cosine is cosine, tangent is tangent, right?
It's like saying mole and mole.
Yeah. Yep, right. Okay, 7 pi over 3. So let's talk about 7 pi over 3 because you don't have a 7 pi over 3 on your unit circle. Let's take 7 and divide by 3. What is 7 divided by 3? 2.3 repeating, okay? But my unit circle goes 0, 0.5 pi, 1 pi, 1.5 pi, and 2 pi. It doesn't go all the way up to 2.3. So it's going around one full circle plus some, right? Okay? So how do I get the angle that it actually is supposed to be?
Well,
Do your best.
Let's subtract that circle. Let's subtract 2 pi from it because that will give me just the little bit that's left over after I do one full circle. So if I subtract 2 pi, I have to find a common denominator, and I want it to be 3. So this would be subtracting 6 pi over 3, right? 7 pi over 3 minus 6 pi over 3 is actually just pi over 3. So all we're doing is we're looking at pi over 3. Do you have a pi over 3 on your unit circle?
Yes.
You betcha. It's in the first quadrant. First quadrant. Okay, so if I make this into a reference angle, we haven't had one in the first quadrant. This was in the second quadrant. This was in the third quadrant. This is in the fourth quadrant. Okay? This guy's angle is pi over 3. What is his reference angle?
180. Pi over 3. Pi over 3.
If you have an angle in the first quadrant, the reference angle is the angle they give you. So reference angle, that's the nice thing. Reference angle is just pi over 3. I don't think they asked for a reference angle in this case, but I just wanted to point out that if you are in the first quadrant, the angle they give you is the reference angle because you don't have to subtract or add pi or 2 pi or anything like that. Reference angle is that guy. Okay? It just is what it is, all right? Then we have to find sine of that value, sine of t, cosine of t, tangent of t. So instead of, we don't have a 7 pi over 3. We're looking at just pi over 3 on your unit circle, which is this guy right here, 60 degrees. We're looking at this stuff, okay? Sine is the y coordinate. What's the y coordinate? Square root of 3 over 2. Cosine is 1/2. Tangent is square root of 3. All positives, right? Because we're in the first quadrant. Everything's positive. Woo! That's a lot of stuff. Okay?
Can you go back to the minus 2 pi over 3? Like how do you know to subtract? The first quadrant was.
Are you on this one? Like how you get from 7 pi over 3 to the other one? Okay. So 7 pi over 3 is 2.3 pi. Right? But my circle only goes up to 2 pi. So we have to subtract 2 pi from this to get it back down and figure out what the angle is. We have to basically subtract that extra circle that it goes around. So we take 7 pi over 3 minus 2 pi, and we find a common denominator, which is 6 pi over 3. Does that make sense? 7 pi over 3 minus 6 pi over 3 is just pi over 3.
Teachers, again, please be sure and have down slips turned in by noon. After lunch, Mr. Carl's
Yeah.
hour class,
Subtract it.
you
So
are to go to
0.3
Mrs.
pi,
Wilson's
which is
room.
just a third
Mr.
pi,
Hunt's
right?
fifth
0.3
hour
is 1/3,
class, you are to
which
go
is
to the lock
that.
therapy. And Mr.
Right?
Muth's fifth hour class, you are to go to Mrs. Feynman's room.
Why did you do 6 over 3?
Because you're subtracting 2 pi.
Oh, where are they going?
Right? 2 pi over 3 minus 2 pi is 0.3 pi, which is 1/3
Because
pi.
it is
Or
bigger than the
you can
circle.
subtract 2 pi from 7 pi over 3. 7 pi over 3 is the same thing as 2.3 pi. Right? So this is subtracting as a decimal. That's subtracting as a fraction. If you subtract it as a fraction, you've got to make it 6 pi over 3.
Also, those students
Okay.
in one.
All right, I'm gonna stop the video.
T-shirts are here in the office.